Okay, I need to talk to you folks about something first. And I need to talk about this word, trust. And for that topic, I will take you back into a search I had 18 months ago. 18 months ago, I went on a quest for buying a new car. Now, well, although that can be expensive and can be quite a hassle, I turned up to having a new car, and it was a brand new car straight from the factory. That car was this one, a deep blue Volkswagen Polo. Not that this is any concern, but the point is, I chose this car because it came straight from the factory, and because I can trust it. If I go from A to B, from the south of the Netherlands to the north of the Netherlands, and I need to take the highway, the only thing I need to care about is putting enough gas in my tank. I do not have to worry about that it will break down, that parts will get lost, that things will jump off the car. But how is that with a car that is a bit older? Say that same car, 20 years old, same deep blue Volkswagen Polo. Can I still trust this one? I'm probably buying it from somebody, but can I trust the buyer? Is that the first owner or the second, third, maybe fourth or fifth? And do I know if it had enough maintenance? Again, a 20-year-old car can be perfectly fine. It can get you from A to B without worrying that it will break down. But I'm not a mechanic. So what do? I probably look if it has a service history. But again, what am I doing now? At that point, I am trusting that piece of paper. I'm basically trusting the engineers. I'm basically making sure that on paper it looks good, right? So, before I go any further, let me get into software development. If we look into software development, say this is a little bit of a story about software development. And normally you start with a small project, a small proof of concept, or a small MVP, however you might call it. And say that is a project, you worked on it worked perfectly fine, and it has strict borders and strict edges. So you have this, a nice little building, a little shed. It exactly does what it needs to do, nothing more, nothing less. It goes into production to your beta user, for instance. Perfectly fine. It works, some feedback comes up, your manager comes up to you and says to you like, hey, can we just add this little button that does, you know that feeling, right? And in the beginning, that's not that much of a problem. So you add it. A little bit out of scope, but still it makes sense. It goes into production, it goes general available, and at a certain point in time, people are requesting features. And your middle manager comes up to you and says, from a business perspective, it makes total sense if we connect this feature to that nice little MVP you built. But then in your mind, you're like, yeah, from a business perspective, this sounds great. But now I have to do a lot of rework to do it. However, your manager comes up to you and asks you like, yeah, but can we do that by the end of the week? And you're like, yeah, fine, we're agile. So you do a little trickery, you do some workarounds, you make it work. It's not the best code ever, but it works perfectly fine. Goes into production again, and then your top level manager comes up to you and says, we have this great opportunity. Let's build this new set of features on that thing that you just built because it drives so much attention. And then you get something like this. You built something, you broke something, you built something on top of other things, and you actually, in the back of your head, you know that that connection, that foundation was actually not built for this. But hey, we made it work, and from the outside it works, right? So if I say it works, probably is. And it goes on and on and on. And it turns out that eventually we are creating software that tries to do everything. That one ring to rule them all, flies helicopters and talks to outer space. Guess what? How much do you trust this building? When it was brand new, right? But do you trust this building enough to live in there with your family? Think about it. Hold that thought. My name is Brian. I am a developer advocate for Sneak, and Sneak is a security tooling company. We create security tooling for developers to make security a little bit more easy, to make sure that while you build, it's easy to think about security and it's not just a science anymore. We're trying to help you with that. And we do some research on it as well. That's basically what we do. I do some work for the community, which is very interesting to do, but that's not what we're going to talk about today, because we're going to dive deeper into that software development. We're going to look into dependency management. And you saw a nice little sketch that I made. I actually made it myself. I'm very proud of that. You see, I'm not a good artist. Let's keep it to software development. I see some thumbs up. Thank you. I appreciate that you liked it. But yeah, well, it's not my core business. Let's keep it to that. But if you look at dependency management, we probably as developers know these kind of things. This is a Java thing, but if you are a Python engineer or an NPM engineer, you probably know about scaffolders. And what a scaffolder does is you click, you mix and match a few of the dependencies you want from a certain framework. It all mixes together and it generates a project for you. Probably a project with a manifest, and that manifest holds a bunch of dependencies. At that point in time, these dependencies are all brand new, latest version, perfectly fine work. But how does that age over time? And how many dependencies are you actually taking in? Great question. So say this is your application. This is the whole binary you put into production. How much of that binary that you put into production, and of course it depends on ecosystem, but how much of that binary that you put into production is actually the code you have written? It is probably something like this. The rest is the frameworks you just imported, the libraries you imported, and the libraries importing other libraries, importing other libraries, importing more frameworks that you just did with that scaffolder. Or even without a scaffolder, you have this. So although you just work on that little small piece, and we are actually proud of that code, we have a bunch of engineers probably here, and I know you're doing a great job. You probably have something in place like reviews or pair programming or these kind of things, some quality checks so that your code is excellent. But how about the rest of that binary? How about that 90% of the code that's actually not written by you, but maybe blindly imported by you or somebody else in your team? How are you handling that? Because statistically, where can the problems be? Both in that little blue dot, but the chances are that it's also in that yellow dot. Take a look at this one. I found this sketch a few weeks ago, and it's funny. It's funny because it's true. We are building software on software on software, and we're depending on dependencies on dependencies. And deep down below, we have that one dependency. Although it looks shiny from the outside, we have that one dependency that's only maintained by one person somewhere in Nebraska. What do you think happens if by accident I drive my new deep blue Volkswagen Polo and run into that person? We do not want to think about that, but it might have some consequences eventually for your project. So, some numbers. We have a serverless example over here. I created this one, I think a year ago or something, and it was 222 lines of Node.js code. Or it was a Spring Serverless example. 222 lines because, Java. Anyway, it had 5 dependencies. And as you can see, some of the dependencies are quite big. Some of the Spring framework and some of them even from AWS. But 5 dependencies end up in a lot more dependencies. In this case, just over 50. $1 million question is, how big is that yellow bowl? How big is that binary? How many lines of code do I actually put into production? Just take a number in your head. You don't have to answer, of course. But my 222 lines of code end up in almost 500,000 lines. And then we can always say, yeah, but you're not using all of this. The first question is, are you sure? Do you actually have any idea what kind of code you are using? Did you create a graph that actually calls whatever? And this is Java. Java has this nice little API we call reflection. How much of that is called underneath while you actually don't know it? Do you have any knowledge of that? How much can you trust it? So, if we're going to do this, we actually need to take care of these dependencies. And we do this in 3 steps. Because, again, we need to trust it in the end. So let's start with step 1 over here. Step 1 is we need to pick a dependency. And that sounds easy. Well, it might be easy if you think of a few things. First of all, how good is that package? But how do you measure that? Think about things of, does it solve the problem? Yeah, duh. But does it actually solve the problem? Or what does it solve anymore? Or what are these implications that it brings when you bring it in? Does it solve the whole problem? I mean, you can solve a problem, but maybe it's just a partial problem and not the whole problem. So I need another package and another package to combine these 3 or 4 to actually solve that problem. And then is the question, do I actually need it? Because it doesn't solve my problem, it just solves a partial problem. Maybe there is a better package. So you need to actually do some research, and more research than just looking on Stack Overflow and copy paste it. So do I need that package? Again, look for instance at your manifest file. I worked on a project a few years ago, and it turned out that if I looked in that manifest file, it had 3 different brands of XML marshallers. Do I need a 4th one? Or actually, do I actually need 3? I mean, they do the same, only with a different syntax. But what happens? People say, I need to solve this problem. I found this. Let's copy paste it in. It works. Never touch it again. Ship it. But also, if you pick up a dependency, how many contributors are there? Is that one person in Nebraska? Or are there a bunch of them? How do they pick these things up? Are they actually active contributors and not passive? So is it still maintained? These are all very innocent and, well, maybe even logical questions. But do you have something like this in place in your company or with your team when you pick a dependency? Think about it. So how can you look this up? I looked, for instance, I made this as a Java presentation, but it's not specifically for any ecosystem you can do this. And I did this for one of the packages I'm a maintainer of, or I'm contributing to. I'm not the main maintainer because I do not have that much time, unfortunately. However, I looked at one of the main repository sites if this package has a nice cadence, has enough releases. And you see that the latest release of this package of Eclipse collections was in August. And mainly you will see it had a bunch of releases in 2020, which is fair, which is good. So I can actually see that if there is a problem, it will get fixed and major releases will get out. Fair, point, tick. So then we look, for instance, at the GitHub repository. It's not that hard, but if you look at the GitHub repository, you can actually see how many contributors are there, how many issues are there. Is there actually an issue with something you need, which requires a little research? But if there's an issue in a known version and they say, we're going to solve this in the next major release, don't try it out yet, or actively contribute to it. Or maybe you should use a different version. Is an issue actually picked up? Is it maintained? You see that the last commit was about 15 hours ago, which is good. It's a highly optimized or a highly maintained package. Another tick. And then we have to actually think about, do I actually need this all? If I just want one specific collection, an immutable collection for a certain primitive, that is all fine. That's part of this set of collection. But do I need the whole binary? This whole binary is almost 10 megabytes. For a Java enterprise development application, it does not matter that much. Or does it? If you go onto the cloud, you pay per storage unit. Or if you actually pull this in, remember that this whole binary is available for you in your memory. It's actually not loaded into memory yet because you're not using it probably, but it is a point of entry. So you're picking a 10 megabyte package and you're only using one collection. Maybe it's easier to use something else. Fair point or not? So we established the point that we picked our dependencies. We have our strategy together. That is good. Now we continue. But at a certain point in time, it needs maintenance. Just like my car, if it's 20 years old, I hope that somebody maintained it and somebody actually maintained it and not just wrote it on a piece of paper. So when do you update dependencies? When your machine says so? Maybe that's maybe that's not a bad idea. But how do I establish that? Well, when do I need to maintain my dependencies? Well, then we come back to basically some sort of the same things as in the first place. We need to think about our dependency health. How good is that dependency over time? Because if I built a dependency on a circuit breaker library that was very good 5 years ago, but in the meantime, it went end of life and a new version or another version is out, maybe that was the cue for me to update to a newer version or to a different one. So it's not just a one-time trick. It's not just only on that first spot. When we pick it, then we're done. No, we need to keep doing that. We need to see if there are regular commits. We need to see if there are regular releases. But also, how do the indirect dependencies work? If I update, do I get more dependencies? Do I get less dependencies? Does it still work? Does it keep working? And we probably all know that because we have a bunch of unit tests that cover our regular stuff, right? But there is a point over here. Our package manifests or our package managers can help with that. For instance, if you're using Maven, and I will show you live right away. I'm having a thing over here, and if I do, let me just one thing. Let me just show you the POM file. And if I show you the POM file, you will see that I have a bunch of dependencies over here. All good. So, and if I'm using just the Maven versions plugin, and I say display dependency updates, it can do all this for me. I do not have to look at manually and see if there are any problems. If you see over here, I have a bunch of dependencies. Some of them are test dependencies, some not. But I can actually see that for Apache Commons Lang, I'm using 3.9 and 3.11 is out. So still, it's up to you if you need to switch them out to newer versions. But at least by automating that, because if you can do this with your package manager, you can also do this in your CI system by just running this after every build or before you going to release the stuff. And now you know that there is a newer version. So you can actually test it. And if the test goes okay, then you can update. The question is, do you want to? And that's up to you. That depends on your context if you want to. But assuming that you have a good test coverage suite, that probably might not be a problem. But think about this. If I'm not updating now from 3.9 to 3.11, that update is probably a very small one. But if I postpone that update and keep postponing that because, it still works, it doesn't break, then I'm just postponing the pain. Because in the end, I probably want something more, and then it relies on other packages or other frameworks, and I need to update it to a higher level. Then I might even need to update to a version 4, 5, or 6, and that might break API. So if you keep these deltas small, it might be very easy to update. Eclipse Collection, for instance, take it as an example, 10.1.0 to 10.4. And I looked into it. The changes are minimal. They basically just entered some new stuff for the newer Java versions, which is cool because it doesn't break my stuff. So small iterations are good. Because if you don't, and I've been in these projects where we needed to upgrade from a smaller Java version like Java 6 to Java 8, and we need to break everything. Newer intermediate frameworks, new frameworks like JPA and Hibernate need to be brought in, and that cost a lot of time. It cost us like months to do this, but we needed to do this because eventually we didn't have support anymore for these older versions. We can do the same for Gradle with a certain command. It's all there. And of course, if you're doing, for instance, npm development or node development, you can use the check updates and you simply do NCU to see if there are updates. So over here, let me enlarge it. I have an npm project. I installed that thing, and if I do NCU, it will look at my project and it shows me that there are a bunch of updates in this project for my dependencies that I declared. So these are easy tools you can use. But more importantly, you can update. Cool. Because, well, actually, if nothing is wrong, you can debate if you want to update or not. But do you know if there is something wrong with your dependencies? I mean, you bring that stuff in, it's that big yellow ball. So there can be an issue with that. And how do you find out? Well, let me demo something for you. I have a small Spring application over here, and it doesn't do much. It is a grocery list. If you see over here, it is a grocery list holding 5 items. Beans, milk, bread, sausage, and beer. All for a certain price. Well, we have my data transfer object, or my domain object, and that basically is a name, a cost, an ID, and some getters and setters. That's because of the verbosity of Java. The interesting part is this one. It's my repository. And I'm extending the CRUD repository of Spring, and Spring, with my scaffolder, gave me all this for free, because now I just have to have that convenience by name. By just declaring a find by name, it will do the CRUD implementation for me. I do not have to write that specific SQL. Same for the find all. More importantly, I'm using Spring Data REST. And now it's getting interesting, because Spring Data REST with this annotation turns my CRUD repository into a REST repository. Interesting. So let me just run this and let me show you what's going on with this one. It runs. Cool. So I'm going to localhost 8080, and you see I'm in my hell browser. And my hell browser is just to show you that my REST endpoints work, because if I do item/1, I will have my beans for 50 cents. Cool. I can do item/2 or 3 or 4, whatever. What I can do as well, I can do something like a search item, and that CRUD repo find by name is turned into a REST repository or a REST endpoint, and I give name is beer, and I will get the beer for $5.99. Awesome. Well, there is, of course, a problem with this stuff. And let me get to the right directory, because I see I removed it for a second. Yes, I've got it over here. So, you probably cannot see it yet, so let's do this again and enlarge this. What I can do with this Spring Data REST, there is an issue with it. There's a vulnerability in it. There is a security issue in this with this specific version of the library, because I can call a curl request, a curl patch request, and I can give it a certain body. And as you can see, or as I tell you, this is the body. And this body is weird. Basically it's just JSON, but it's JSON with some tricks in it. It calls the Spring expression language, an expression language in Java, which allows me to interfere with the objects, and also gives me the ability to create new objects. And that's fun, because what I'm doing here is I am calling the runtime. So I'm calling calling the current runtime, and I basically execute a command. What does that mean? if my user has enough privileges on that system, I can basically call any command, Linux command, that this user can actually execute. So let's try this. So I'm using this one. I'm going to do this command. And you see it's a curl patch request with a header which says application JSON and with a certain body. And in this body, I'm not calling command anymore. I'm calling env, the environment variables. But I launch it on my localhost item/1, which gives me normally, with a get request, gives me the first item in my grocery list. By doing this, you see that I actually expose the environment variables of my current system. So what happens over here? Quite simple. We're going into an exceptional flow because it doesn't know this body. And in that exceptional flow, we were allowed to, unfortunately, execute the expression language. And if I'm able to do that expression language with this body, I'm able to get that runtime. And I'm able to use the environment variables command. But I'm also able to make a directory, delete a directory, make a file, delete everything. So I can do a lot of harm. And by implementing or by using the wrong version of this. However, this is already fixed, right? If I am doing something like a scanner on my application, and I'm using the scanner that my company provides, it can scan your, not in the exploit folder, of course. That is quite silly because, but if I do it in the main folder, it will get my manifest file. It will look at all my dependencies and it will see if there are problems with the versions I have. And if there are newer versions that can help you fix this, if there is a fix available, because most of the problems are already fixed and there are newer versions out and people might just want to change that. So if I go up, and it's a bit enlarged, so it's probably not very good readable, but it says upgrade this version from 1.5.5 to 2.1.16, and you fix all this trouble. More importantly, I can also connect my GitHub repository, and I did it over here. And then you see, hey, there's an arbitrary code execution. I just showed you this exploit. And it is on Spring Data REST. And it says, it's quite a high score because it's a very mature exploit. There are exploits, mature exploits, and there is a fix. Give some explanation. So you see there is tooling available that can help you with these issues. And you should be doing this in your maintenance phase. Cool. So, well, we can go over this. These are numbers on how many vulnerabilities are there in different ecosystems. Trust me, a lot. And most of these vulnerabilities are not in the packages you actually import. These are in the so-called transitive dependency. So the dependency depends on the dependencies and depends on other dependencies, etc., etc. And deep down, 3, 4, 5 levels deep, there might be a library that is vulnerable, that has a very small vulnerability, which might seem innocent, but if you punch it with the right amount of force in the right spot at the right time, you might be able to see the environment variables or worse. So instead of only looking at newer versions, you also must be aware of, if I'm not updating to newer versions, or even if I'm updating to newer versions, are these versions secure? Okay, we had step 1, we picked. We had step 2, we had the maintenance phase, which is fairly good. And then we have step 3. In step 3, which is basically the last step, we need to get rid of dependencies. Or do we? Well, my Mac says my disk is almost full, so I might need to make sure that I do not have lots of binaries that are not used anymore. But think about it. If you're in that car, if you're switching out parts, do you leave the old part in the car or just throw it away? If I would do that, within 20 years that car exists, my trunk would be full of crappy old dependencies or parts that I'm not using anymore. And that's the point. When are you not using it anymore? This is a Maven POM file For Java developers, very, very known. But the point is, this is the dependency part of that POM file. And I could have shown a Maven or an NPM node package.json as well. But this is line 977 to 1023. And these are only partially the dependencies that come in. There are a lot in this old project. And the point is, there are a lot of dependencies that are still there that are not used anymore because, well, the program evolved into a big giant thing that can fly helicopters and talk to outer space. But I built things, I broke things off, I built new things on top of them, I maintained them, and at a certain point, I might not even be using a certain package anymore. And again, your package management tool can help you with that. So if I'm looking at Maven, I can use the dependency analysis tool for that. And it is just there. So if I'm using this command, and you see it says dependency analyze, and just for fun, I will move the ignore away. And then you will see, hey, there are dependencies declared that are not used. Well, this one is logical because it's test dependency. And of course, there is no path in my production code that goes to an H2 test dependency. This one is provided, which normally says it is provided by the application server, or I do not bundle it in my binary. But this one is important. So with that -d flag I just showed you, we get rid of all the fuss and we end up with only the compile dependency that I showed you here. But just to show you this is not really fancy. But again, your package management tool, and if it's Maven or Gradle or NPM, and I'm certain that PyPI has it as well. But these tools can help you, or there are tools available that can help you to do the heavy lifting for you. So Gradle itself doesn't have it yet, but there are a bunch of plugins you can use. For instance, a Nebula plugin, which works perfectly fine. And for NPM, you can use dep check. But again, it will show you that you are having dependencies that you're actually not using. And by that, you can start your research like, am I not actually using? If I just get rid of it and I run my test suite, does it still work? Because if I'm not using it, and it's still part of my binary, somebody else might, still need to maintain it. Still need to make sure that it's up to date. But if it's gone, I do not have to worry about it anymore. And I honestly like a clean desk policy. I honestly like, if I'm not using it anymore, I throw it away so I do not have to care about it anymore. Keep your dependencies clean. So, basic steps. There are three things you have to think of when you're building your dependency strategy for your own company or team. Pick, update, and remove. These three subjects you need to discuss. If we look at these three things, there are a few things I want to give you at the end of this presentation, like what kind of stuff do you actually need to take with you if you want to implement this tomorrow? Because it's a process. And it's not the most fun thing to do, but you see there are tools that can help you. First of all, we need to include something for a good reason. Do I need it? Do I need all of it? And isn't there a better solution for it? Specifically, if you're using Node.js and NPM, there are a bunch of different projects that do exactly or almost exactly the same. Which one is the best fit for your problem? Because your problem might be a little bit different from all the problems that are on Stack Overflow. Check the dependency health when you pick it, but also over time. Keep doing that in a recursive job. Every time you're built, why not automate this? Or maybe you should check it every time you're going to production. If there are newer versions, and most important, if that version is, if that dependency is still maintained. Scan for security issues often. Why not scan on your local machine like I did? Why not scan your repository? Why not take a snapshot of your dependencies and monitor that over time when you go to production. Because when you're in production, a new vulnerability can still be found. Again, there are tools like the ones my company provide. Update often to newer versions, because if you keep that delta small, the pain is not that big. The pain is there's not a lot of pain to change it. It might be a change of API, but you know it early, and if you postpone it, the pain will be bigger and larger and enormous, and well, it might be and you cannot. I think you cannot describe that to your manager like, now, because we didn't do this, we need to rebuild everything. And then he or she probably asked, why didn't you do maintenance in between? Because you're maintaining the stuff. If you keep that small, it are just small jobs that you can incorporate in your sprint tasks already. Simple Boy Scouting or Girl Scouting. Removed unused dependencies, we talked about that just yet. Make sure if you're not using it anymore, it cannot be a problem, or it shouldn't be a problem, so get rid of it. If it's not in your system anymore, you do not have to care about it anymore. If you need to reintroduce it, fair enough, but then you get the first step again, introduce it. And of course, there is a lot of automation available. First of all, buy your package managers that can do this. And if you can do this by typing in something in your console, you can also do this by automating this in your CI system. And I will not say like you need to break your build if there is a newer version, or you need to break your build when there is a security issue, but be responsible. If you say, hey, this is a fix and it needs to go into production now, and I don't care, fair enough. But at least you are aware, you can put it on your backlog and you can give it a certain priority. And if there is a security issue, you should give it a high priority, but that's my opinion. However, you can automate this stuff. It doesn't need to be hard. I know that people used to get back to these websites and manually do these things. Please don't. There is a lot of stuff available. So again, what we want to do is make sure that your program is trustworthy, because people, just like the engineers on your car, trust you, the maintainer, that if you say it's okay, that they can trust it. So we just have to make sure that your program is just as trustworthy. Oh, as you can see, it's in multiple versions, but your program is just as trustworthy as that brand new car that just came from the factory.